So we are doing the May-June 2022 paper 3-3. May-June 2022 paper 3-3. Question number 1. I hope that you're also opening your paper so that you can read as I'm reading also. In this experiment, you investigate an electrical circuit. You have been provided with a wooden strip with a wire attached to it. This is our wooden strip. There is a wire. I hope that you can see this wire. There's a wire attached to this wooden strip. There's a nails here attaching this wire, as you can see. Measure and record the length L of the wire between the nails on the wooden strip as shown in Fig 1.1. So I'm going to put this down and I will use my meter rule to measure and record the length of the wire on the wooden strip. Okay, so the length is approximately 75.3. So I was supposed to measure and record the length L. So it's 75.3 centimeters. Okay, so next. You have also been provided with a wire labeled A with crocodile clips at its end. So we have a wire labeled A here with crocodile clips at its end. This is the wire, let me take it out. Labeled A with crocodile clips at its end. Then next, set up the circuit shown in Fig 1.2. So we have a circuit shown in Fig 1.2. I think you can see it on your papers. A circuit shown in Fig 1.2. So we are supposed to set up the circuit as shown in Fig 1.2. So then after setting up the circuit, then we will continue. So I'll put my paper there. I'll try by all means to create space so that we can set up this circuit. So on setting up this circuit, always start with the power source. Now, this is my power source here, and this is the positive of the power source. This is the negative of the power source. It's a 1.5 volt battery. So in this circuit, as you can see on my circuit here, I will follow this pattern. I'll move from this power source, the 1.5 DC power source. I'll enter the resistor, exit the resistor, then I'll go through this way. Then using this crocodile clip, I'll connect to the wire of the wooden strip. I'll exit here, then I'll come back. That's the first circuit that I'm going to connect, as you shall see. So here is my wooden strip. There is my power, my battery, my power supply. So I will then connect, as I told you. These are our connecting wires. They've got crocodile clips connected at each end. So I will take my crocodile clip. Yes, they'll be mixed up like this, but you need to be careful when taking them so that you don't break them. Okay, so I'll connect this one starting from this side. Then remember I said that I'm entering this resistor Y. My resistor Y is given here. This is a holder of the resistor. This actually is the resistor here. So this here is our resistor there. This is our resistor with the color coding there telling us the resistance. But this is a resistor Y. So I'll clamp it on the resistor holder like that. It's just a holder of the resistor there. So I'll come then, since I need to connect this connection to this resistor, I'll connect this crocodile clip to this end because my resistor is here, and as it is here, I connect this crocodile clip like that. Then I take another wire, there, crocodile, another connecting wire. Okay, so I connect this one. Since if we follow this circuit, we can see by following this circuit that we come here and we enter to the wooden strip. So I'll bring this one to this end. So I've connected this one like that. It comes here to the wooden strip. Then if we can go back, we can go back through here. This is G, and then we go back to the switch. So from G, this part here, I'm going back to the switch. So I'll take another wire. I'll go number 1 to the switch. Now the switch does not have a positive or a negative. This here is my switch, so I can enter the switch from any side. Then I'll exit the switch. Then I'll exit the switch like this. Okay, do not allow these connecting wires to mess up the circuit. I'll exit the switch from here, and I'll then connect to the negative of the battery, like that. Okay, so I've connected the first round of the circuit. The second round of the circuit is this one that starts from here, enters through voltmeter 2, exits here, enters through voltmeter 1, and comes back here. Okay, so I'll start from this point here. From this point, that's why I'm going to start. This is a multimeter, which we are going to use as our voltmeter. In this case, for it to operate as a multimeter, if I were to use it, I can switch it on like this. Since the maximum voltage in the circuit is one cell there, which is 1.5, I will set my voltmeter at 2. By setting it at 2, it means that the maximum voltage that it can measure is 2 volts, which is fine because it allows us to be more precise. And whenever you're connecting your voltmeters, remember which is the positive side and which is the negative side. So for example here, I'm starting from the positive of the battery, coming like this. So the question is, which one of these two is then connected here? It is the positive one. We always enter from the positive of the battery into the positive of the voltmeter. So here we are going to enter from the positive of the battery into the positive of the voltmeter. From the positive of the battery into the positive of the voltmeter. So I'll start from here. I'll make sure that the connections are secure there and they're strong enough. I enter into the positive of the voltmeter like that. Then I'll exit from the negative of the voltmeter. I'll exit from the negative of the voltmeter. Let me use another secure cable. From the negative of the voltmeter. And again, there's another voltmeter here, voltmeter V1. So I'll enter into voltmeter V1, the other voltmeter here. So this other multimeter will work as my other voltmeter. So remember, I'm coming from the positive of the battery like this. So I must always enter into the positive of the multimeter. I'll adjust it, of course, the multimeter, so that it is on and it can measure a maximum of 2 volts. Then from here, I go back to the point F has been shown there. Okay, so I'm going back to point F. So now, as you can see, my table is all clogged. So I'm going to remove some of the things so that at least I can move back my things. This is what you must do when you're doing the practical. You must move your practical so that everything is well spaced, so that there is no connections that are not clear to you. For example, as you can see here, this created a disharmony now like that. So I'm moving everything so that everything is clearly visible and everything is in order. Okay, so now that we are here, everything is on. So let me put this one on this side so that you can see clearly. Now, we are left with this branch now, which starts from the center of voltmeter 1 and voltmeter 2. It comes to the wire. Remember, we have a wire labeled A, and this is the wire labeled A here. My wire labeled A, this wire here. This wire labeled A is connected at point G. At point G, which seems to be this point here. And then it is connected to another point labeled point F, point H, like that. Then from wire H, from point H, that wire is then connected. From point H, this wire is then connected to the middle of voltmeter 1 and voltmeter 2, like that. So I will take maybe the last crocodile cable. Let me see, one which has no problems. Okay, so I'll come here now because there's a connection from here. So it can be anywhere, either here or here, because that's the middle of the voltmeters. So I will connect it here. Remember, there must be an electrical connection. You cannot connect with a wire on top of this red here. That's actually not a wire, that's an insulation. So now I think When it is like this, I can remove this and I can put them down. We are left with everything that we need on the table now. Okay? So now the question then asks you, if GH are crocodile clips, the distance between one of the nails and the H is D. So the distance from this nail to H is D, as shown in Fig 1.2. Attach H to the wire on the wooden strip so that D is approximately 20 centimeters. So we need to attach it to the wire H so that D is approximately 20 centimeters. So to be approximately 20 centimeters, it will have to be from here to there. So let me adjust this one like that. So it is from here to here. That's approximately 20 centimeters. Remember, it is supposed to be approximately, not exactly. We can never work with exactness. Close the switch. Now we are closing the switch. And to close the switch, this is what we use to close our switch. Okay? So as it stands right now, we have reading in 1 voltmeter. We have readings in 1 voltmeter, but we have no readings in the other voltmeter, indicating that there might be some loose connections on the other voltmeter there. So these are things that you must check in the exam. Now we have a reading on the other voltmeter now. Okay? Record the value of D and the voltmeter readings V1 and V2. Okay, so let's remeasure again D. Okay, so let's remeasure again D. Remember, it has to be an approximate value. So by remeasuring D, I measured again D to be 20. So I'll write it as 20.1 centimeters. That's what I saw there. But there seems to be a loose connection because, as you can see, the value is changing so much. So there is not a very good connection. There seems to be a very loose connection somewhere here. Now it seems as if it's now more stable now. Okay, so this is the voltmeter reading V1, but again it's moving, indicating that something is not right here. When it is moving like this, you should know that something about the connection is not right. But anyway, when we adjust it, it comes back to around, as you can see, it's flashing between 0.200 and stable at 0.200. And we write it as it is there with all the decimal places there like that. Okay. Okay. So next, the voltmeter reading V2 is 0.629. Okay. So next then the question says, increase D by placing H at different points on the wire and record V1 and V2. So we are supposed to place H at different points on the wire. So now you must use the breadth of, remember, whom are you changing? You are changing D. So if you are changing D, the question is, what is the minimum possible value of D? Remember, D is measured from here to here. So the minimum possible value of D, we can agree. Let me maybe make this connection a little bit more tight here. Yes. The minimum, let me just readjust this one again. Yeah. The minimum possible value of D, we can agree that it's from here. From here to here. So D can be adjusted. We can adjust this wire here. Let's try by all means to make sure that this wire doesn't make other contacts, unnecessary contacts with what we have there. So we can adjust this one to bring it even to this point. Like that. So we can lower as much as we can, or we can bring this as much as the wire A allows us, which means we can bring it to the other side like that, as you can see. So we can bring it to the other side like that. We can bring it to the lower end. So D can be varied across all those values. So since D can be varied like that, we need to have a good and a wide range. So I'll start from here so that we can have a good and wide range. All the times, make sure that there's good contact, number one. Number two, make sure that there's also no loose contacts everywhere else, because there might be some loose contacts which might affect your readings. And also see when the readings are stabilized. So just wait as I'm taking another ruler. Okay, I need a smaller ruler here so that things can work well. So with this smaller ruler, I can measure some of these measurements without much problem. Okay, so from here to here, I think we can all agree that it's approximately 7. Okay, so it's approximately 7. So the question said, increase D by placing H at different points on the wire. I record V1 and V2. Repeat until we have 6 sets of values of D, V1, and V2. So D, V1, and V2. So the first D, as I showed you, it's 7, which is 7.0. Then V1, it is 0.08. It's fluctuating between 8.3 and 8.4. So if you average that one to be 8.4, like that. Then on the other side, it's 0.761. 0.761. Remember, it also said that we can include our values from B. Now, for me, for starters, I will start off by having the extreme values, so that I will make sure that I will never make the mistake of having a problem with range. So I've put it on to the other side also now, making sure that there's no contact here, waiting for it to stabilize. Now I need to measure the length D, because I need all the possible extreme values all at once, so that I can actually, I can guarantee that I have used the entire range. So this gives me approximately 72.2. 72.2. 72.2, and my V1 is steady at 0.552, whilst my V2 is steady at, it's almost alternating between 0.057 and 0.058. So the average will be 0.058. Okay, so now I have 2 sets of values, and I'll take the other value that was already there, which was 20.1, which we had done already. For 20.1, V1 was 0.200, whilst V2 was 0.629. Now, as you know, as you are doing this experiment, there might be some errors which can be made. Sometimes they are loose contacts, so sometimes you might have to redo some values. So now, I'm going to change now so that I can have at least 3 more values which are distinct. So I'll bring it here. By bringing it here, it has stabilized a little bit. So as it has stabilized, let me see so that I can remove these other contacts that might be there. It has stabilized a little bit. So now the distance from here to here, it's approximately 50. Remember, what we want is the approximate reading. So it's approximately 50, which is 50.0. And the value of V1 is 0.400. And the value of V2 is fluctuating between 0.329 and 30. So I think that is stabilized at 29 there. So it is 0.329. Okay, so now we have 4 sets of readings. Then I'll move this again, because it was at 50 now. I'll move it again to this point, a new point, which is slightly different. It need to be, for there to be a very big difference. Okay, so having moved it here, this is approximately 43.0. 43.0. And 43.0, if you see the value of V1, it is 0.350. It's stable there. And the value of V2, it's fluctuating between 0.304, 0.304. So it's 0.404, like that. That would be the average. Then we are left with one reading. So the question is, how scattered are our readings? We have 7, 20, 43, 50, 72. I think maybe we may need a value probably in the 30s, around 30 there. So let's move this one so that we can have a reading close to 30. Somewhere there. Okay, so let me measure this again. Close to 30. I think it is close to 30. Okay, this is 33. So 33.0. It is stabilized at around 0.248. Whilst the other one, it seems to be off. I don't know why. Okay, it's on again. It's 0.450. 0.450. As we conclude, before we conclude, we need to just check whether there is a trend. Trend means that as the values of D increase, at least the values of V1 should either increase or decrease. So for 7, we had 0.084. For 20, we had 0.2. For 33, we had 0.248. For 43, we had 0.35. For 50, we had 0.4. For 72, we had 0.55. So it seems as if as D was increasing, V1 was also increasing. Let's just check the relationship between D and V2. As D is 7, V2 is 0.761. As D is 20, this decreases to 0.629. 33, 0.5450. 43, 0.404. 50, 0.329. 72, 0.058. So it seems there is a trend whereby as D increases, V1 increases, but V2 decreases. So it seems our values do not intermesh. At best, we have done the best quality possible. So that is fine now. Thank you.